I'm going to show you what I did to troubleshoot a problem with my water heater. My water heater wasn't working. My water heater has a Honeywell gas valve. And when I came out to look at the problem, there was no LED status light blinking. This chart over here indicates what a problem may be based on the number of flashes on this LED status light. But I didn't have an LED status light to rely upon to indicate what the problem was. And you likely won't either. The reason the LED status light wasn't working is this. I had no pilot light. You need a pilot light to operate the thermopile, and that's a thermopile right there. When the pilot light is lit, it envelops and heats the thermopile. The thermopile then produces enough electricity, it's just a small current, to operate the control board in this gas valve. So if you don't have a pilot light and the thermopile isn't being heated, to operate the control board in this gas valve, you're not going to see any status light here to indicate what the problem may be. So now I'm going to show you what I did to troubleshoot the problem and determine what it was. You'll have a cover down here to remove, and the way you remove it is you pinch it or just pull it from one side and it'll come off. The first thing I did was test whether the igniter was working. The igniter has two parts to it, or two components. This part, which is the igniter switch. The second part is on the burner assembly in this combustion chamber, right back there. That's the actual igniter, or the igniter head. Now the way you test the igniter switch and the igniter is very simple. You have the temperature knob in the off position, and you click the igniter or strike it, like this. While you're doing that, you look down through the sight glass to see if you can see a spark. So you click the igniter and look for a spark. If you see a spark, your igniter works. So after you know your igniter works, the next step depends on what your situation is. In my particular case, I couldn't even establish a flame to test what's called the thermopile, and we'll be doing that here soon. So what I mean by that is I would turn the temperature knob to pilot, press it in, click the igniter, and I would see no flame at all. There was nothing. So I wondered if it might be the actual pilot or pilot head down in the burner assembly that was somehow plugged up, the orifice on it. So the orifice on the pilot head in this particular configuration is a slit, a small slit. It's not a hole. So what I did then, because I couldn't even establish a flame to test the thermopile, I removed the wires going to this gas valve, which are these two wires, the igniter wire, and the two wires over here on what's called the thermal switch. I then removed these two tubes. This is the pilot tube. This is the burner or manifold tube. They have gas running through them. So you want to turn off your gas before you remove a burner assembly. That is the first thing you do. Then you remove the wires, remove these two tubes, and remove these two screws down here. Once you do that, you'll be able to pull out your burner assembly. And when the burner assembly is out, you can clean the pilot head. And the way I did that was this. I blew out the tube here, right there, with compressed air, and I used this. It's mass airflow sensor cleaner. It's called MAF cleaner. It has a high flash point. It dries very quickly, so I cleaned it just to make sure that it would be completely clean. This is very good cleaner for carbon buildup, and that's why I used it. So while I had the burner assembly out, not only did I clean the pilot head, I also cleaned the thermopile and the igniter. I used a very fine piece of sandpaper. It doesn't matter what type you use as long as it's a fine grain. I used that sandpaper to clean the head of the igniter and the head of the thermopile. Once I cleaned the pilot, the thermopile, and the igniter, I put the burner assembly back in, and I could then establish a flame. It wouldn't stay lit, but I could establish a flame to check my thermopile. If you don't want to remove the burner assembly, the easiest thing to do is turn the gas off. Again, the gas is off, and you remove this pilot tube right here. You loosen the fitting, pull it down. Be careful how you move around this tube because it's delicate. It's aluminum. So you pull that down and you get some compressed air, shoot it through that tube, which comes out the orifice at the pilot head, and clean that orifice out. Sometimes those become plugged. In my case, it was plugged. It was partially plugged. That's why I couldn't even establish a flame. So if you can't establish a flame, meaning you turn this temperature knob to pilot, press it, hit the igniter, and you can't even see a slight flame, that is what I'd do. I'd remove the burner assembly, clean that pilot, or I'd blow some compressed air through this line. Again, that's all with the gas off. But if you can establish a flame, a pilot flame, by turning this temperature knob to pilot, pressing it in, and striking that igniter, if you can establish one, not meaning that it will stay lit, because it will not stay lit, but if you can even raise a pilot flame, you can check your thermopile, and you don't have to take out the burner assembly or blow any compressed air through the tube. So let's talk about that case. So in this case, you can establish a pilot flame by turning the temperature knob to pilot, pressing it in, holding it, and striking the igniter. In that case, you can check your thermopile. So either way, whether you have to take out the burner assembly because you can't establish a pilot and clean off that pilot head, or whether you can establish a pilot flame to check the thermopile, I'm now going to show you how to check the thermopile. So to test the thermopile, you want to isolate it. So you're testing only the thermopile. And the way you do that is you remove this red wire from the left side of this thermal switch. That is called a thermal switch. You pull that wire off because you're going to need that to test the thermopile. This red wire runs directly to the thermopile on that burner assembly. This white wire runs directly to that thermopile on the burner assembly. So by removing the wire from the thermal switch here, we've isolated the thermopile to test that alone and not the thermopile and the thermal switch. So I'm going to set up my tester and I'll show you how I did that after I set it up. All right, y'all, before I set up the multimeter to test the thermopile, I want to add, if you have the burner assembly out, you're going to have access to your thermopile. And you'll have these two wires, this one and this one, the white one, because it all comes out together. You'll have those wires accessible too. So you can test that thermopile with a flame. So get a lighter and test it just the way we're testing it now, which is what I did so I knew my thermopile worked. But I'm going to show you how to test a thermopile when the burner assembly is in. So we have our red wire that's going directly to the thermopile that we've taken off this thermal switch. We remove this little, what I call a wiring harness right there. It's just a little harness that keeps the red and the white wire to the thermopile in. So you rock it back and forth and it'll come out. We have our multimeter set up. It's on DC, direct current, and 2000 millivolts. I have the red lead from the multimeter going to the red wire that we took off of the thermal switch. The black lead is going to the back of this white wire here, of this harness that we pulled out of here. So, black lead from the multimeter to the white wire, red lead from the multimeter to the red wire. And now we're going to test that thermopile. All right, y'all, let's test that thermopile and see if it works. Here's how you do it. You move the temperature knob from off to pilot, and you press in that temperature knob. You strike the igniter. You see how our numbers are increasing here? That means our pilot is lit because it's applying flame to the thermopile, which is generating electricity to operate this control board. What we're looking for is 650 to 850 millivolts. So it'll take a couple of minutes. Keep pressing in that knob at the pilot position. All right, y'all, it'll continue to climb slowly, so I know that my thermopile is good. I have a reading of over 650. And now I'm going to release the temperature knob and you'll see what happens. The numbers will start to decrease because there's no longer a flame from the pilot to heat that thermopile. And there you go. So now we know our thermopile is good and it's healthy. So now what I'm going to do is show you how to test out the thermopile with the thermal switch attached to see if the thermal switch may be a problem. So I've taken the lead off of the red wire that went to the thermal switch, and I'm going to put that red wire back on the thermal switch now. And what this test is going to show us is whether the thermal switch might be giving us some resistance and causing a problem. If it doesn't give us resistance, we're going to get the same numbers or very close to the same numbers on the thermopile test that we did when we bypassed or got that thermal switch out of the way and tested that thermopile directly by isolating it. So now what you do is you take the lead, the red lead, the positive from the multimeter, and you put it in right here, behind or in front of, this is just the way I test it, behind where the red wire comes in on this wiring harness. You can put it behind or in front of directly. So now we're going to test the thermopile with the thermal switch hooked up and see if that may be causing us a problem. So here's our setup to test the thermopile with the thermal switch attached to see if the thermal switch might be causing us a problem, giving us some resistance. I've got the red lead from the multimeter attached to the red wire right there, the red wire on this little wiring harness, what I call a wiring harness. I've got the black lead hooked up still to the white wire. I just put them in the back. You can put them in the front if you want. So now we're going to test the thermopile again and see if that little guy over there, the thermal switch, might be giving us some trouble. Alright y'all, now we're going to test the thermopile with the thermal switch attached or in line with it to see if that thermal switch may be giving us a problem. So we do basically the same thing we did before, just to test the thermopile itself, isolated. Turn the temperature knob to pilot, push it in, light the pilot. We know the pilot is lit because the numbers are increasing. It's heating up that thermopile. So we're going to test that now. The reason you have to keep the temperature knob pressed in is you're manually operating the pilot valve. You see those numbers rising? Those are healthy numbers for the thermopile test. So now we know that the thermal switch is not giving us a problem, is not the problem that's causing the water heater not to work. There could be a little bit of resistance between the thermal switch, but not much to be concerned about. So I'm going to let go of the temperature knob again, and you'll see the numbers decrease. Alright y'all, at this point I knew my igniter worked, my thermopile worked, my thermal switch worked, and what I suspected was the problem is one of three things. Either low pressure in the gas line, which I didn't think that was the problem, the temperature sensor, which is at the back of this gas valve and goes into your water heater tank, but I didn't think that was the problem, or the control board itself on this Honeywell gas valve. Behind this cover on this Honeywell gas valve is a control board. Beyond that is the actual gas valve itself. It's not common for a gas valve itself to fail, particularly on these Honeywell gas valves. It's typically the control board. So what I wanted to test next was both the pilot valve and the main burner valve on this gas valve. So not the control board itself, but behind that on the actual gas valve. And I'm going to show you how I did that right now.
Nice.
All right, y'all, the first thing you want to do is turn off the gas supply to the gas valve. Turn the temperature knob to off and disconnect the igniter wire. You just pull it right out, like that. remove the thermopile wires by rocking this little what I call harness back and forth. Take that off. There's a screw on the lower left side of the cover on this gas valve, and it takes a Torx bit to remove that. So the best way that I've found to remove this cover is rotate it at the bottom just a little bit forward, just a little bit, being careful not to break or pull on these tabs at the top. There are two plastic tabs, retaining clips, that keep this cover on. Then I take a small screwdriver and work those retaining clips free, just a little bit at a time. The cover comes off. On the back of the cover, you'll see 3 wires. Those go to your temperature sensor that goes inside your water tank through the back of this gas valve. I don't like to remove these wires before I remove the control board because the connector is delicate. So I'm going to remove the control board first, and I'll show you how I do that. The first thing you want to do is get these 3 wires out of this retaining clip that's located right here. And here's how you do that. Just a little screwdriver to push that retaining clip up a bit, and they come right out. Now you use a Torx bit to remove the screw holding that control board in. What's holding the control board in now are 3 retaining clips. There, there, and there. But before we remove those or move them back to remove that control board, I want you guys to take note of this locating pin and this black arm right here. That black arm comes off the temperature knob that's on the front of this cover. So when you're removing this control board, you want to keep that fairly level as you're removing it, not to one side or the other. Just as level as you can, so you remove it slowly, because you don't want to harm that arm coming off the temperature knob. You don't want to misalign it. So you can use your thumbs if that's what makes you comfortable. I like to use a little screwdriver and just work up the control board a little at a time. So I release that one, I push the retaining clip back. I'm going to do the same on the bottom here. This tends to be the toughest one, the one on the bottom right there. So I'm going to push it down with the screwdriver and work that up. Now there's this one over here. There you go. Now that control board is released from those retaining clips. And I'm going to take my fingers like this and carefully work that up like that. That's the soldered joint side of the control board. And here's the component side of that control board. Now here's the connection for these 3 wires. I push that little clip down in the center and work that connection off like that. So put your control board off to the side in some place where it won't be damaged. So now the control board is off. The reason we remove the control board is so that we won't damage the control board if it's good. We're going to test the pilot valve and the main burner valve. This pin right here goes to the pilot valve. This pin right here goes to the main burner valve. This pin down here is the ground. So these pins are almost in a V shape like this. Pilot valve, main burner valve, ground. So the way I tested the pilot valve and the main burner valve to see if they're working properly is I used a 9-volt battery with a negative terminal and a positive terminal. What I did was use gator clips. These are gator clips, y'all. You can also use just wire to do this test, but if you use the wire, here's what you do. You have to have 2 different wires. One that leads from the negative side of the battery on this post, the terminal, to the ground, and another wire that leads from the positive terminal on this battery to both the pilot valve and the main burner valve at different times though. So I'm going to show you how I tested this. If you guys do use wires to hook up to the battery, you want to make sure that the wires, the metal, does not touch each other. So put some tape around it or something like that. So I took one gator clip and attached it to the negative terminal on the battery. The other side of this gator clip, right here, I attached to the ground pin on the gas valve. Then I took another gator clip and put that on the positive terminal on the battery like that. I'm going to lay this battery down over here so you can see this test. So before we test this, we have the negative terminal on the battery going to the ground pin on the gas valve and the positive terminal on the battery right here. And so what I want you to listen for, I'm going to touch the pin of this pilot valve and you're going to hear clicking. That clicking will not be the result of me touching this metal to that metal. You're going to hear the clicking because the pilot valve is going to open if it's working. So listen to this. You hear that clicking? That pilot valve is opening up and working. So now we're going to test the main burner valve, and you'll hear the same thing. If it's working, it will click. You'll hear a clicking noise, which is that valve opening up. So here we go. Again, the pilot valve, the main burner valve. And that's how I tested the pilot valve and the main burner valve on this Honeywell gas valve to confirm that both would work and that that wasn't my problem. Both of these work. You can hear the clicking or opening of those valves, each of them. So after I did all of that troubleshooting, I knew that my problem was not the igniter, was not the thermopile, was not the thermal switch, was not the pilot valve, and was not the main burner valve. What my problem was the control board on this Honeywell gas valve. They fail, and they fail often. That's what I had to do to determine what the problem was on my hot water heater that wasn't working and had a Honeywell gas valve. You can purchase the control boards on eBay. You just have to have the model number of your Honeywell gas valve. Once I knew that my problem was the control board and that that had failed, I didn't want to replace the entire gas valve. There was no need to because the gas valve was working. It's just that the control board had failed on me. So what I did is I went to the Restore in my area and purchased a brand new gas valve for $50. My Honeywell gas valve, this is the old cover, this is the new cover. Both of these Honeywell gas valves, the model numbers begin with a WV. W like William, V like Victor. And the reason I wanted to stay with a Honeywell gas valve model that began with W William V Victor is this. On these models, if you have a high temperature shutdown, which is a 4-flash error code, you can reset the control board and override that control board so that you can put your gas valve and water heater back into normal operation. The Honeywell gas valves that Honeywell put together to replace these models that begin with WV begin with WT, W like William, T like Tom. If you purchase one of those gas valves or the control board on the gas valve that goes on the model that begins with W William, T Tom, you cannot override the control board if you get a 4-flash high temperature shutdown. I was not going to have that because I know how to override the 4-flash error code from a high temperature shutdown. That is why I wanted either a control board or a gas valve model from Honeywell gas valve that started with a W William V Victor. So my recommendation would be if you have a Honeywell gas valve and you've tested it as I have today and have shown you, and the gas valve itself tests out fine, it's just the control board that has failed, I would just replace the control board. Now I'm going to show you how to put the control board back in the cover and put that back on. Take the connection, put it in, make sure it's secure, rotate the board. Get your cover and carefully place the board in the cover, and the way I do it is I locate that black arm from the temperature control knob and that locating pin, and I gently place it on like that. It'll start to in a seat. Now you can either use your fingers or a screwdriver to push back those retaining clips to get that board in. I'm going to use my fingers in this case. Just push it down a little bit. On that side it's engaged, on this side it's not. Now the board is fully seated. Make sure that's secure. Replace the screw on the board. Again, make sure your connection is secure. Put the wires back in the retaining clip. Just work them in. There you go. The screw is in. The connection for the 3 wires is in and secure. And the 3 wires are back in their retaining clip. Now you're ready to put the cover back on. You rotate the cover with the board in it. Push these 3 wires into the cover. So the trick to getting the cover back on is this. You want to gently feel around, you're doing it blindly, for those 3 pins that are protruding out of this gas valve to be seated on that control board. So just gently place that cover on and work it around a bit until you feel those 3 pins go into that control board. And you'll feel it when they seat because you won't have resistance. Just keep working it around. Don't bend those pins, y'all. Just be careful and take your time. So I can feel that mine are seated. And there she goes. She snaps in. Replace the screw on the cover. Now with the cover on, reconnect your igniter wires. Reconnect your thermopile wires. Turn on the gas supply to your water heater. Move the temperature knob from the off position to the pilot position and press and hold the temperature knob in and strike the igniter. I heard my pilot start. Continue holding in the temperature knob for about 30 seconds to allow the gas to flow through and heat up that thermopile to operate the control board in this gas valve. We should see a light once. There it is. This status light will blink once every 3 seconds if this gas valve and water heater are in normal operation mode. And there we have it. I continue holding in the temperature knob for about another 30 seconds so that it's heating up that thermopile to operate the control board in this gas valve. Release the temperature knob. Turn the temperature knob to your desired setting. I do not go past hot because these Honeywell gas valves will lock out and go into 4-flash high temperature shutdown status if the water is too hot. and the burner just came on. And that's how you troubleshoot a water heater that's not working, that has a Honeywell gas valve. Hope it helps, and happy DIY.